Hey everyone, this is Mayur. In this video, we'll talk about what is standard deviation and how it is helpful in machine learning. So, standard deviation is a measure of variation of your data point or a dispersion of your data point around or against the mean of your data points. Okay, consider this as your normal distribution and you have a particular feature and you have the majority of your features value are centered around 0, and standard deviation is a data point which is revolving around your mean. Okay, there is something called as low standard deviation and also high standard deviation. As low standard deviation is a point consider here 0 is your mean. Okay, assume it is 0, and then any point which is close to 0 is considered as a low standard deviation, and any data point which is far away from 0, for example between 2 and 3 standard deviation, is considered as a high standard deviated point. Now coming to how standard deviation is getting measured, let us see this example here. We have 8 data points here, and first we calculate the mean of these data points, which is around 5, and then standard deviation is nothing but square root of variation or variance. So how variance is calculated is use of your data point minus the mean value. Okay, and the square of that is your variance, and square root of that, which is nothing but your standard deviation. So that's how standard deviation is calculated. Now what we'll do is we'll perform the same set of operations and try to understand how it is helpful in machine learning. And let's get into that first. Yeah. So here we have a data set of height and weight based on genders. So let's see, we have gender, height, weight, and as mentioned in the Wikipedia page, let's do something called as calculate the mean first for the height. So this is the mean height, and then we look at variance, which is nothing but this is the variance. Next, the standard deviation is nothing but the square root of this variance. So data dot height dot standard deviation, which is nothing but square root of 14.8, is 3.8. Now, how it is helpful in machine learning? So what does it even mean actually, the standard deviation? So you have let us plot this first height. How does it look even in the first place? Let's plot that. So is it following the normal distribution or not? Histogram will plot. Now, I guess I did not import the package required for plotting. Import matplotlib .pyplot as plt and matplotlib inline. Okay, why no model? Okay, one sec. Let me install matplotlib. So it's getting downloaded. So let's wait for it to get completed. Yeah, it's done. Let's see how it works now, this particular piece of statement. So yeah, so this is the histogram of your height. So this will give us, it almost looks like similar to a normal distribution which has like standard deviation from mean, which is 65, almost 65 to between 67, which is the mean, and you have something standard deviation between 55, 1 2 3 standard deviation, which is spread across till from 54 to 78, 79. Okay, so let us understand how it is helpful in detecting outliers. So consider a data point which comes in, a new height, a person's new height comes in, and we want to understand if this person is following the trend of this normal distribution or he is far away from the distribution or in terms of standard deviation. So there are like already we have a bunch of data points from which we calculated the mean, okay, earlier. So if you see here, we calculated the mean, which is 66, and the standard deviation of 3.8. Now, as I said, any point which is beyond 2.5 standard deviation is always considered as a person who is an outlier from the distribution. Okay, so let us see data dot height, and the standard deviation we have already calculated. So at 2.5 of that, okay, is around 9.6. Now 9.6, let us also take this point, which is the height dot mean plus 9.61. okay, we get around 76, okay, which is around here somewhere, which is beyond like 2 standard deviation, which is 2.5 standard deviation. So now what we'll see is what are the number of people, how many number of people are there who are beyond this specific data point. Now if I go data dot height, and then if I do something called as data dot height, which is greater than 75.9 or 76, okay, now we'll see a bunch of people. Okay, there are too many people with the height greater than 76, which also means there are like a lot of people with who have value greater than 2.5 standard deviation. Now if I want to count this, okay, this function, there are like 38 people. So what is the total number of records there present? Number of records are 10,000 and 38 people have height greater than 76. Okay, these 38 people act as kind of outlier in this distribution. And similarly, okay, now this is the 2.5 standard deviation. This is an upper threshold since we are adding it. Okay, this is an upper threshold, and if we do something called as minus, we have a 56.75, which is around here. And people who are beyond this, okay, in terms of lower side, are considered as outlier in this case as well. So what we can do is 56.75. okay, we can take this value and put it here, and we'll get the count of number of people, not greater than, it's less than that. So around 25 people have height less than 56.75, and they are also considered as outliers in this specific scenario. So this is how what standard deviation helps in machine learning to understand how the data point with respect to mean is spread across, and how it acts as a outlier in specific scenarios. Because if we have these outliers in your data set while training a model, okay, it will not help us in generalizing the model for regular cases, because outliers don't happen frequently. So this will kind of affect the model in generalization. Yeah. Thank you.